Okay, this is the third and last video for section 7.3. Talking about right triangles with an altitude drawn in from the right angle to the hypotenuse, creating similar triangles, and then applying it with some different theorems. So this last one, still a geometric mean theorem, but now we're talking about finding the length of the legs. So what I mean by that is the length of the leg of the biggest right triangle, x, or this leg, y. Okay, it says in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. So that's just setting up the picture. This is the main part. Hopefully you hit pause and are copying this down, all of it. So the main part says the length of each leg of the right triangle is. So let's just look at one at a time. And again, where these things are coming from is similar triangles. You're just setting up similar triangles and comparing corresponding sides. So the length of each leg, we'll do one at a time. So x, the length of that leg, AC, x, is, that's the equal sign, the geometric mean of the lengths of the hypotenuse, which is AB, times the segment of the hypotenuse that is adjacent to the leg. So if we're looking at leg x, the adjacent part is AD. Okay, AD is right next to AC. So the length of each leg, so we're looking, in this case, we're looking at x, it is the geometric mean. So x equals square root of a product, geometric mean of the lengths of the hypotenuse, so the whole hypotenuse, AB, and that part of the hypotenuse that's closest to the leg you're looking for. So that's this formula, and that is where this proportion, those two things are related to each other. So now, looking at the other leg, side Y, that leg is the geometric mean of the hypotenuse, the biggest hypotenuse, that's AB, so it'll be multiplied by the part of that hypotenuse that is adjacent to the leg, so right next to it, that's side DB. Okay, this geometric mean here is coming from that set of proportions. And again, the proportions are comparing corresponding sides of similar triangles. I'm just turning these words directly into a formula so that it makes it a little bit easier to deal with when we're solving problems. So let's try to solve some problems. Okay, so we're looking at this picture. We have a big right triangle. We got this altitude drawn in from the right angle to the hypotenuse. 10 is the leg. It equals the geometric mean of the entire hypotenuse, which is 24, multiplied by the part of the hypotenuse that's adjacent to the leg that we're looking for. So the part of the hypotenuse that's closest to the 10 is B. All right. So to solve for B, this is the setup, but to solve for B, we just got to get it out of that square root, which means square both sides. So we have 100 equals, when you square a square root, they just cancel each other out. So we're left with 24 times B, the stuff inside the square root. To solve for B, just divide by 24. So B equals whatever that is. 4 is a common factor, that's 25 sixths. I think that's as simple as it goes. Okay, so that's that problem. That one's done. Now, looking at the next question, number 8 here. So we got a bunch of stuff. We got a couple of variables to solve for. So looking at it, we know z. So if we go back to the first geometric mean theorem, finding that altitude is the geometric mean of the two parts of the biggest hypotenuse. So that's y and x. I don't know either of those. So we're going to come back to that to eventually solve for z. Now, to solve for x, we know this side 14. So that leg is the geometric mean of the hypotenuse, where the whole thing, that's 16, multiplied by that part of the hypotenuse that's closest to the leg, which is x. So this is very much similar to example number 6 that we just did. To solve for x, we're going to square both sides. 14 squared is think 196, but I'm getting the calculator out just to double check. Yeah, 196. That equals the square root and the square cancel each other out. 16 times x is what we're left with. Divide by 16. X is 196 divided by 16. Oh, it's 16. That's nice. Wait a minute. Something's not right here. I'm not hitting the right buttons on the calculator. Made an error here. It's not 16. 196 divided by 16. There we go. Sorry. 12.25. That equals x. Okay, so now, if x is 12.25 and the whole hypotenuse is 16, that means y equals 3.75. Just segment addition postulate. So now, to solve for, we got x and y, now we're missing z. Now we're back up to here. So z, the altitude of the biggest triangle, is the geometric mean of the two parts of that hypotenuse. So that's going to be our 3.75 multiplied by the other part, which was our 12.25, and back to the calculator. So secondary square root of 3.75 times 12.25, and we get a nice clean answer of 6.77777208. You get the idea. All right. There's both theorems in action. We solve for x, we solve for y, which allowed us to then solve for z. That is how these problems are done. I hope you enjoyed this. Have a good day.